pun, that's gonna sting for a bit. It's gonna take a couple days to like wear off. Can everyone hear me? Okay. All right, good. Yeah. All right. So yeah, I was trying to figure out I wanted to find in preparing for this talk, I wanted to find an image that would really kind of capture the essence of what Backbone Conf means to me. And I had struggled to do so until last night, by a stroke of good luck, I stumbled across the perfect image, and here it is. I don't really know what else to say. Boaz and Sam having a good time, sharing pasta, just hanging out. So anyway, yesterday people talked about all kinds of uses for Backbone. Personally, I've been using it for a long time, but the only thing I've ever really done with it is build single-page apps. Now, the first thing about that is I actually really hate this term. I think it's kind of silly. It doesn't really embody what these things actually are. All the ones I build kind of have this concept of pages and whatnot within them. It's like it seems like a silly phrase for this, and I feel like we do better. And there's kind of this native versus web thing, and it makes the web port kind of, people seem to think of it as almost like a lesser thing sometimes. And I think that's backwards. And I think, if you're building for iOS, you're building a native iOS app. What that means is you're building, using the tools and libraries that are native to that platform, right? And, what we're doing here is we're building apps with the tools that are native to the web. So I think we should call them native web apps. I think that's much more descriptive for what these actually are. And we're using JavaScript, HTML, and CSS to build apps. The delivery mechanism is actually secondary to that. So anyway, the point is, your browser isn't your renderer. It's not just drawing the document that you got from the server. It is in fact your runtime. And the definition of this has been kind of expanded a bit to be, arguably even like web views and whatnot, right? They're also your runtime, right? But the point is you have this kind of web runtime that you're using, and you're building native apps for that runtime, right? No matter what you think about all that stuff, one thing that's very clear in the industry is that more and more logic is moving to the front end. And, lots of people with lots of different backgrounds kind of are moving into that space as a result of kind of recognizing that they want to build these richer experiences, right? And in doing so, they bring all their backgrounds and experiences with them. And so they bring their favorite patterns, their favorite preferences. And so we have this plethora of options for approaches for various things, right? And yet somehow, Backbone is still very, very broadly deployed. It's been extremely successful. And as Jeremy tweeted a while back here, the top 3 newspapers by circulation in the U.S. are all Backbone apps. That's just one little niche. That's not a small thing. And so it might not be like the hottest topic right now because it's been around for a while, but these are still very much like, they're very, very broadly in use, right? So I think it's an interesting use case, and we can think about, why is it that Backbone has been so popular? And I think we can find some of the answers just by reading the homepage on the docs and kind of seeing the philosophy. And it says this: Backbone is an attempt to discover the minimal set of primitives that are generally useful when building web apps. And in an ecosystem where overarching decides everything for you frameworks are commonplace, Backbone should continue to be a tool that gives you the freedom to design the full experience of your application. So if I were to try to distill that down, really it's two principles there: minimalism and flexibility. And Jeremy, if I'm wrong, now's a good time to let me know. Okay, all right. But then, the other side of that is, if you take a very minimalistic approach to the tool set, that means that there's more stuff that it doesn't do. By definition, right? So there's gaps that we have to fill, and if we're, building apps like this a lot, we notice there are in fact other repeating patterns that Backbone does not address. That's not a critique against Backbone; it's just fact, right? And so the question is, well, then how do we deal with that, right? And how do we fill those gaps? The approach that we see a lot of is kind of the add-ons, right? Where you have, like we saw yesterday with Marionette, et cetera. And, in talking to folks who use Backbone at some of these larger companies, like, they've all kind of done the same thing. They've kind of built their framework on top of Backbone to some extent. So it's almost like they treat Backbone as kind of this meta framework, and then they build theirs on top of it. So, that's kind of interesting, right? But another approach would be to just be like, whatever, it doesn't do what we need it to do, so we're going to throw it out and use something entirely different, right? and that is more encompassing, that has all the things that we need. And so that's where you get your Embers, your Angular Polymer, in combination, React and Flux arguably could be put in this list as well. And I think that's where I think that's what's being referred to here in terms of the overarching decides everything for you frameworks. You're kind of going all in when you do that. You're saying, okay, I'm going to just jump, head first into this thing, and hopefully it solves all my problems, right? And the thing that I find interesting about this is that they're higher abstractions. They're usually quite a bit higher in terms of abstracting. And what you end up with as a result is that you learn the abstraction. There's this really great quote by Chris Gale, who was the former vice president of engineering at Yammer. So obviously, he doesn't know what he's talking about. I mean, he only sold his company to Facebook or to Microsoft for $1 billion, right? But so he said this. He said, "I'm more interested in optimizing a person's understanding of the problem than I am of the solution," and that just really kind of hit home with me, and I totally agree. So, and I yanked that quote from Marco Rogers, who used to work at Yammer, and he might still work at Yammer. He gave a really great talk, kind of finding patterns across JavaScript frameworks at JSConf 2014, I think. So, what's that? Was it at TXJS too? I saw the video I saw was from, whatever. And maybe it was. Who cares? Anyway, great talk. Definitely go check it out. I work at And. There's about there's about 30 of us. We do a lot of consulting. We do, so we have about 30 developers, but we have 40 people roughly. But we write lots and lots of different types of applications. So we're constantly kind of thrown into a new scenario, a new project. And so we don't just have like a product that has a certain approach that we're going to use over and over and over again. And so we come across like a very broad range of problems. And I'm one of the partners in the company, and so I care a lot about not just what we're doing now, but like where are we headed in terms of investing in skills that are lasting here. And I really want our team to be awesome JavaScript developers. I want them to be really familiar with the problems, not necessarily to be really amazing Ember developers or really amazing Angular developers. I want them to know like how to solve the actual problems here, and then not abstract too far away from that. So the third option I would suggest is to actually not have a core at all. And what I mean by that is, I to give you a little bit of background. I started using Backbone at like 0.3 or something. I forget. It was a long time ago. And we were starting to build something that did similar approach, and then Backbone came out, and I'm like, all right, let's just use this instead. And for years we've been kind of gradually building out this set of add-ons and things that we saw repeating patterns that we wanted to solve once and move on. And I came from kind of writing a lot of Django. Who here has written Django? Oh, quite a few. Okay, cool. I absolutely love the models that are in Django. They're very declarative, very readable. And I kind of missed that when moving to Backbone. And so we built our own, eventually we built our own kind of model layer for Backbone. And that forces you to be much more declarative about what you're storing, etc. And also we kind of, roughly around this time, Node was coming out, and we started really using Node for lots of things. And Node has this very kind of unique mentality of everything being these very small modules that you install with NPM. So, we started using NPM and CommonJS modules for our front-end code as well. And this was before Browserify was a thing, just because it seemed like such a nice way to structure code. We kind of fell in love with that pattern, right? And then I wrote a book about it, kind of finding my, kind of summarizing my conclusions and whatnot. It's free to read online if you want. And, the thing is, like, as crazy as this may sound, after having kind of completely fallen in love with that approach, like, I think even Backbone is too monolithic. Like, throw tomatoes now. That's a good time. And I don't mean in file size. I'm talking about coupling specifically. And let me explain a little bit. So, one thing that is a good example of this is the fact that models are useful for modeling other things, right? Take for instance, you have, say you're building, hypothetically, you're building an SDK that has a real-time connection of some sort that you're managing its state, right? It's perfect use case for a model. You want to be able to set what the current state is. It could be connecting, could be connected, could be trying to reconnect, it could be disconnected, etc. Like ideally, you just want some little observable object that you can set a state on it and watch for changes to, etc. and react to accordingly. So that's a really useful use case, right? And another one that we ran into is like being able to model touch events in like a touch library. So if you've never done this before, the way that this works is you get a touch start, you get a touch move as you move your fingers, and you get a touch end. That's it. But a lot of times if you're building applications that have kind of this rich touch type interface, what you want is you want to know when there's like a hold event, for example. So you don't get that out of the box. And it's not trivial to compute it, right? Because what you need is you need to start a timer when you put your finger down. You want to be able to let somebody wiggle their finger a little bit. So you have to track X and Y and then distance from that original point. And then you have to start that timer, and then at some point you're going to trigger that, hey, you're holding this thing now. So that's for a single event. Then if you want to do gestures, now you have multiple fingers. And so maybe, I don't know, putting those in a collection. Like, so modeling them with the touch gestures with models and collections actually makes a lot of sense, right? It's very useful to do that. Now, the thing is, if I do this with Backbone, then the thing is I end up including, my view code, the router, collection, and this is meant to be a library. This isn't an application. This is just that little library. And in addition, then now there's a dependency on jQuery whether I use it or not, and an underscore as well. So and kind of a specific version of each of those. Like there's kind of a assumed, like, I don't necessarily want to just assume that those are going to be on the page, and I don't want to tell people when they're using my library that those should be there, right? So eventually we kind of decided to go a different route, and we did fork Backbone. As you see by this clever illustration here, we started out with kind of a plate of spaghetti, and then this ampersand grew out of it. It had a backbone, and then it lost the backbone. Yeah, okay, so we built on Backbone first, and then this is really just kind of the evolution of the stuff we've been working on for a long time. And the other thing is that the name is actually just a filthy lie, like, because there is in fact no such file in the whole thing. There's nothing that you can just put, like, include ampersand in a script tag. That file does not exist in the project. In fact, we just needed to name it something just so we could have something to talk about. Because, like, hey, I built an app with lots of different modules. Like, hey, like, no, it's a kind of a curated set of specific tools, right? But in fact, there's nothing in the whole project that you can just drop into a script tag without a build step. Like, we're at a point now in JavaScript development, like, everybody should have a build step, because you got to minify and gzip and whatever else you're going to do anyway. Like, you might as well, and you're going to want to structure your application in some way that makes sense to you as a developer, and ultimately, deliver something in a compressed format, right? So we have a build step anyway. So, like, why not just install dependencies, shove it all together and send it out, right? And so everything is in separate CommonJS modules and in separate repos. So they're individually installed via npm. If you want to use a model, you have to go install that model from npm and use it. And you get just that model. You don't get everything else, right? And then you build it with Browserify or Webpack or any number of these tools. There's more coming out, it seems like, frequently. So so this is kind of what we ended up with, kind of as kind of a, if we look at Backbone, what Backbone provides, this is kind of what we provide. And if you're building a real-time application or just modeling state without doing any sort of RESTful stuff or really persisted models at all, state is kind of like the bare bones state management piece that just does, like, here's your core state management is an observable object, essentially, is what it is. And then, we have the model, which really just extends state. And if you look at the package JSON file for that, it's just requiring state and extending state, and off you go. And then collection and REST collection is the same thing there. The collection itself is very, very bare bones in terms of you can store whatever you want. You can store, just plain JavaScript objects if you want, and get events and stuff out of it. Obviously not model events if those models are not emitting events, but adds, removes, that kind of thing, right? And then if you want something that's much more like a Backbone collection, then you have the Ampersand REST collection that includes, the sync stuff and all that sort of stuff, right? And of course, a view and a router. So the other interesting thing about, doing this that we realized is, since we don't really have a core, we don't have to be all that selective about what we make and include, right? Because, you know, if you're shipping everything in a single file, like, you got to be picky, and you should be picky, because not everyone's going to use everything. But in our case, like, you're just installing gradually, so we can build other things. Like, so we have, you know, we have a CLI, we have this kind of app pattern that's useful for kind of thinking about your app globals, etc. View switchers, you know, and then helpers around, you know, managing forms, etc. So these are things I would never want to see in Backbone Core because they don't belong there, right? But, you know, as a result of having this very kind of shopping cart mentality, you go, I need this, I need this, I need this. It doesn't matter. We can ship those things as well, right? And they're all kind of individual GitHub repos. And you know, I know this is for Jeremy really. He loves Semver. You should go read his thoughts on Semver. They're actually quite. I disagree, but I still enjoy reading them. But they enable this kind of thing for us. Like, it's actually really useful for us when we're, you know, whenever there's cross dependencies between these, to be able to just, if we strictly follow it and we can trust that we're following it to the best of our ability, nothing's perfect, right? Then we kind of get that ability to upgrade without having to go, you know, upgrade hard-coded package files in a bunch of different places, right? So it's really useful for us. If you're curious about what it looks like side by side, and just in general when comparing frameworks, this is a really useful tool. Most of you have probably heard about it, but the Ampersand is on there as well. They asked us to add it, so we did. So, I mean, you might be thinking, yeah, whatever, so what, who cares? Flexibility, modularity, go home. But, you know, the interesting thing is you end up only sending what you use to some extent. You know, there's obviously always a little bit of dead code, but like way less than you normally would. And so to do MVC, all the JavaScript assets for that combined, when you minify and gzip, it comes down to 28 kilobytes. Like that's nothing. Like that's smaller than jQuery is by itself. So that's kind of interesting, especially when you talk about loading on 3G or what have you, right? And also, you know, the other thing about that is like there's a recent study that came out. I forget the exact details. I'm sure you could find it by Googling, but basically that measured parsing performance of a bunch of mobile phones. And, you know, it's not just downloading the assets. So then if you have a bunch of JavaScript, you got to parse and execute all that stuff as well, right? Parse, compile, etc. So, you know, the less you have, the faster each of those steps go. And I still think, you know, that matters, right? And the other thing about going really modular is that you can remodel the kitchen without burning down the building. And, you know, that's kind of a crude way of saying it, but it really is true. You can replace pieces as you need them. If some aspect of your tooling isn't doing what you need it to do, like you can replace it, and you can replace just that one piece without having this huge like file size increase, or you can kind of mix and match a little bit better, right? I have no idea how that slide got in there, especially after the last one. That's weird. So speaking of you know, modularity and being able to swap things out, so as a bit of a test, like I think React is a really interesting concept. And a very cool library, and they introduced some cool stuff. And so, you know, I wanted to try this out. And so I built the To-Do MVC app. I tried to convert the one that we'd already built to use React plus Ampersand. So it used React for the rendering layer, right? And that was an interesting exercise because, you know, I could just replace, I deleted 2 Vue files and then wrote 2 like React components, and that was all the code I had to change. So like that's all the data layer stuff still made sense. Everything else was, you know, and all I did on the React side is just anytime the model changes, just force an update. So, you know, it wasn't that big of a deal to swap out just a portion of it to use something else, right? Or to convert the whole thing in this case. But, you know, again, modularity is not really the only feature here. We forked for other reasons as well. So just we wanted a little bit more power out of our model layer, as I implied earlier. So one example is kind of these smarter, stricter models, right? In Backbone, you know, you don't have to define a specific model. You can just, you know, store a name and then observe the name change, right? But you don't have to define that anywhere, right? And but the thing is, like a lot of these times, especially if we're treating kind of our models as the source of truth for our client-side application, like especially in a team setting, like it's really important to us that those are readable. That's the thing I loved about Django is like you could throw another developer on a project, and you know if they go read through the models files, it's like you have a pretty good idea of what you're storing. You kind of see what the relationships are. you can figure it out fairly easily. And we wanted that same thing here. So, so we make you define what you're going to store in a model. And so, here you have ampersand state. So it has you see this props thing. So here we're creating the same thing. So we're creating a property called name, and saying it's a type of string, right? And so you can still set it like you normally would and watch it, of course. A few interesting things is you can actually, this simple assignment here, the model.name, will still fire the event. Because we know what properties you're going to store, we create a getter for that, a getter and setter for that property as well. So we can make it observable even from simple assignments. So, people have different feelings about that, but you can do it if you want. And then the other interesting thing is like if you set it to a number that doesn't match the type, it throws. So it's really useful for catching errors and something like checking your assumptions in your application as you're building. Like you think a value is whatever, and then come to find out it's not. And actually having it blow up on you is extremely useful when you're building. And so you can kind of configure what it does with properties you haven't defined, etc. But we find that useful. And the other thing, session state. This concept of session state is really useful, I think, in client-side apps, where you have data that's very specifically related to a model in a collection, but you have no interest in persisting that anywhere, right? Things like this item is currently selected. I'm sure it's useful for that view, but I wouldn't put that in a view. I would put that in the model because other portions of your app might want to know what the selected model is, right? So having that stuff in your model layer makes sense. And of course, there's ways to do this in Backbone. You can just override to JSON and delete it when it's coming out, right? But what we do is we just say, we have this other thing. So you can define any number of other session properties, and they work the exact same way. The only difference is they don't get serialized, right? So, yeah, that's useful. Another kind of interesting approach is having these getters and setters. I mean, getters and setters in general are kind of contentious topics. It's a little bit messy sometimes. You can certainly shoot yourself in the foot with these. But they're useful for models because what we can do is things like this. We can say, hey, today is a type of date. And then I know from the server I'm going to get it as a Unix timestamp. It could be a string. It could be a number of that Unix timestamp. And so I can set it in that way. But when I get it, when I go retrieve it, it's always a JavaScript date object. So you don't have to worry about kind of those transformations. They just kind of happen for you. And again, you look at your model and you can just kind of read that, right? Another thing that we added here is kind of this concept of kind of cached observable derived properties, which is a really long way to say computed properties. So they're defined like this, right? So what you do is you can just say, hey, this thing is derived, and you can list as many of these as you want. So nickname in this case, what we're doing is we're saying it's dependent on the name property, and this is how it's calculated. Really easy. It's only one way. You can't set through these. But if you just for the next slide, go ahead and remember that all that we're doing for the nickname is taking the first 3 characters here from the name. So then what happens is we can observe that in the same way. We can read that property without using calling a function or whatever. So as far as your template's concerned, all you see is nickname. And then if you set it to something different, if you set the dependent property on something different that still produces the same result, it still doesn't fire, right? So it caches and compares against its cache, which obviously there's performance overhead for doing that, but it's really useful for a lot of things. So so in this case, setting it to Henry after it was already Henrik, it wouldn't change because the first 3 characters are the same of the computed property, right? But if we change it to something completely different, then it fires, right? So being able to easily declare and observe derived properties is useful too. So, and you can derive from child models, you can derive from other derived properties. You can use these to manage relationships between models, which is useful. So if you have, a known cached collection of models somewhere else, and you have an ID in your model that's a property, you can then go, hey, give me the related model, and you can define that as a derived property, which is useful kind of managing those. Can't set them directly, and again, the theme, resulting code is more readable, right? So I'm not going to go through too much more detail than that. Definitely if you're interested, just go check it out in the docs. And we also have a pretty active Gitter chat thing. If you haven't used Gitter, it's great. It's like a web-enabled IRC for GitHub projects, but you can also connect with IRC. So yeah, come say hi there if you want. So once you kind of start down this path, as I was implying before, you kind of look at everything through this lens. You're like, man, I don't want to like I don't want to include stuff I don't need. I don't want to like have any larger dependencies. I want all these little small things that I can use, right? And it's kind of addicting, and arguably in certain cases not useful, but other times it is. When you're building libraries and you're trying to include just a minimal amount of stuff, like it's really quite useful. So then the question is, well, what about underscore? Well, if we look at npm, it's by far the most dependent on package in all of npm. Right? First off, bravo Jeremy, he's got 2 things on here. You look at that and you go, well, I wonder how many of those really are just using 1 or 2 methods, right? I would venture to say there's probably quite a few, right? It's not bad necessarily, and if you're on the server side, it's completely inconsequential. Like, who cares, right? And arguably, if you're building a whole app, yeah, by all means, just include underscore, use it, and be happy. Like, there's no reason that you're going to use enough of those things where it's worth it, right? We're not talking about huge file sizes here, but when you're writing library code, it feels a little bit like, I don't know if I want to do all this, like I said before. If I'm wanting a single function, if all I want is a nice, cross-browser, each that I can use that I know will work on, whatever browser you throw at it. What if I just want that, right? People end up doing silly things, right? So you take library code that otherwise would have, dependencies, and they just kind of rip out a few portions of them and include them in line. So, this guy made this mini score thing and just created, a few methods here that he wanted from underscore. I don't know if he copy and pasted. I don't know if he, whether he, I don't know exactly. I don't know if they're tested well, so how do I know whether they're cross-browser? He's, re-implementing this stuff. And there's obviously not, if there is a bug fix, like, it's not just going to come in upstream, right? And then what about jQuery? Arguably it's the same thing, right? Ideally, I want this as well. Like, I want to be able to have a cross-browser add class that's optimized for newer browsers that just works. Like, if that's the only thing in my library that I need from jQuery, I don't want to be dependent on jQuery. And, so I want individually installable, cross-browser tested, as much as possible APIs that never get updated. Because why would I ever need to, right, in that case? And that are strict semver as possible, right? So if my add class method supported all of these APIs, so you could either add a single class, you could add multiple classes as different arguments, or you could add an array of classes. Like, why would that ever need to change? That API contract should stay the same forever, right? That makes sense? If you understand semantic versioning, what I'm saying here is that major version number should never change, right? Which means that there's never going to be breaking changes to that API, right? Everything is an optimization. You might have, the implementation details might change, but there's no reason you have to break that API. So for items like this, I want these things to exist. So obviously there's Lodash, and people ask about this as well, when they show them what I'm about to show you. But the thing is, those are all versioned together, and you can kind of install individual pieces from it. Some of them had kind of oddly, deeply nested dependency trees that make me kind of wonder a little bit, and I'm not too excited about. And again, I don't want those APIs to ever change. I don't want my npm outdated to show me that Lodash is now at 2.6 when all I did is use that one add class method, right? Or which doesn't exist in Lodash, but something like that, right? So prepare your tomatoes again. I did other crazy things. So what we did is we made this project called AMP. And AMP is just what I've been talking about, which is individually installable modules that do one simple thing. It's a bunch of utility modules that do one thing. And as it turns out, maintaining tiny piles of ridiculously small modules is a giant pain in the ass. Who's tried this? Like, managing dependencies between these, like, if I come up with a better way to test these, it's like, I don't want to, like, it's ridiculous, right? If you have them in 40 different GitHub repos, like, good luck. Yeah, you're going to change your testing approach on 40 different GitHub repos. It's just not going to happen, right? So no, with that, and I think this is quite relevant here. Another flaw in the human character is that everybody wants to build, no one wants to do maintenance. I find this to be true. So what we did is we put everything in a single GitHub repo, and then just basically scripted the crap out of it. It contains about 40 modules right now, and to add a new one, all we had to do is add an item to a list in a category. So we edit a JSON file, run a build script, and it creates an empty doc, implementation, and test file for us. We go fill those things out, and then we run the build again and push it. So, and then we cross-browser test everything with a CI system. So it's using, it's IE6 plus. Not that we were targeting IE6, but once we did 8, we got 6 for free. So apparently nothing happened in 2 versions. We'll just leave that be for now. Microsoft is doing good things these days. But then we use Travis CI to trigger a process on Sauce Labs that runs it through a bunch of different browsers, and we can run them local. We can run all the tests locally as well, of course, using Node or Phantom or whatever to run them locally. So we end up with a shared documentation site and simple names that you can memorize, which is useful. One of the things about digging into Lodash modules is they kind of have these categories, and they have you got Lodash / modern / whatever. And also, when you browserify things like that, it's using those paths. So ideally, you want those names to just be as simple as possible, right? So what you can do is just, npmi-s save amp whatever. So, and they're all kind of named with the hyphen. So add hyphen class, for example, right? And you just add them as you need them. There's about 40 of them on there now. A lot of them, basically huge credit to Jeremy and the underscore people. A lot of them we ported tests over and just implementations too. So it's very much inspired by underscore. But then we added our own things and we kind of tweaked some things that we wanted to be different. And everything's on that shared doc site, and including the implementation. So inline in the page, because we're just requiring a few things and then we have a few lines of implementation. You can also just go read the test. You can go read the entire implementation in the doc site right there. So if there's any ambiguity about how this thing works, just read it. And because the documentation stuff is all separated out from the individual published module, it just links back to the site. It means that those individual modules never really have to be updated unless there's something broken or something that we need to fix, right? So anyway, there's about 40 of them now. There's about 5 more in pull requests at the moment, I think. But we'll keep building that as we need them. But again, for things that are very small, very reusable, very much like I don't ever want to think about this again kind of problems, right? Okay, so those 2 things. There's the last thing I want to talk about is the view layer. I would say that's easily the most contentious, most painful portion of any native web app, right? Would anybody disagree with that statement? Is that not the biggest source of pain? Can everyone agree? I mean, maybe I'm alone here, but okay. So Philip and I. So Philip works on Ampersand with me and works at India. Awesome guy. He's been playing with React for a while and got really into it. He's like, hey Henrik, you got to check this thing out. You got to do it. And so we've kind of been going back and forth on this, and kind of wanted to share some R&D that we've been doing in this space. And when I say R&D, I mean very recent R&D. Like we started this. We've been talking about these problems for a long time, but we actually started working on this probably 5 or 6 days ago. So very, very, very recent. But templating on the server as a concept is very, very simple. Right? You've got your template, you've got your data, you smash them together, and you send it down the pipe. That's easy to understand. You don't have to think about that, right? But on the client, obviously, we're mutating state. We're dealing with state that's changing over time. And, the DOM is stateful. And so we have to have a way to sync our state to the representation of that state that we want the DOM to display at any given time. And we want those things to be really fast. We want them to be really, live updating, feel really responsive to a user. And so, and Marco, I think, said it really, really well the other day. So this is a reminder that the DOM is actually a giant mutable global variable in the middle of your program. Act accordingly. It's true. I mean, it's kind of there as a consequence of kind of how things used to be done. If you've ever written something for like a canvas or something, where you just refresh all the time, you just redraw all the time, and you repaint, and you can do so inexpensively. You can't do so inexpensively here. And I think Jeremy called it. I mean, it really is like in a finished backbone app. You know, if you take kind of the recommended approach, you don't have to write the glue code. You know, that looks into the DOM, finds an element with the specific IDs, and updates it manually. You know, when the model changes, you just redraw the thing. The views update themselves, right? Ideally, we just be able to redraw. Now, we always know that that's not necessarily always the right solution, right? So, for a more concrete example, say that we have this, right? So the top is our current state of the DOM, and then after we render in the state of a particular view, let's say, and then at the bottom, that's the target. That's what we want to end up at. We want to add that. There's a new paragraph tag there. So the simple way to do this is, you know, if the element contains that entirely, you just set the new inner HTML to be just that string, right? The browser parses it and puts it in there for you, right? And if it's infrequent and if it's simple enough, like that's fine. There's no reason to overcomplicate these things. Like, you know, a lot of people over optimize here, I think, and I think that's Jeremy's point in the docs. Like, if you're not like if this isn't happening all the time, and if you're responding to some user action to change some state of a view, like you don't need to bind it. Probably you can probably just redraw the thing, right, and be happy. But for larger sections of DOM, or if the user input is part of that, so if somebody has a focused input inside that element and you redraw, they lose focus. So there's a few cases where this really doesn't apply all that well, right? So, you know, hypothetically, wouldn't it be nice if we could do this and say, you know, call this magical mutate element function, which I actually think should be part of the DOM. But, you know, where you pass it an element and you say, hey, this is my target HTML. And then what it would have to do is it would have to go, okay, there's a new p tag here, so I'm going to create that element. I'm going to set its content and then append it. So if this mutate function was smart enough, that's what it could do, right? Then we only update what's actually different, and you know, we don't thrash the DOM without reason to, right? And you know, the other nice thing is if the DOM is in fact the same, we don't do anything. Whereas if we kind of blindly re-render, that's going to happen even in the cases where the resulting HTML is not actually different, right? So, and arguably it's a little bit wasteful, right? So this concept, we didn't invent this concept. It's this concept of DOM diffing. Ding. But basically, if we could do this with higher performance, then all of a sudden our whole binding problem becomes much, much, much simpler, right? Because then it's just like server-side rendering. You run it through your template, be happy, right? And so if you're not familiar with React, that's essentially what they did. They approached this problem saying, you know, I think we can do this performantly, and which is really interesting. And you know, so if you were to smash the two together, it might look something like this, where you have, you know, you create this, instead of your view, you create this React class. And you know, what I'm doing here is just in get initial state, just creating this, assume that this model is a backbone model for example purposes. And then anytime the model changes, force update of the component. And the force update will then, you know, run this render function. If you haven't seen this syntax before, they're doing HTML inside JavaScript, which is, and then so basically transforming the code ahead of time and compiling it down to JavaScript functions, because it's kind of ugly to write. So they wanted to make it as simple as possible. So then you kind of just return, your render just returns the new React virtual DOM is what it is. But the downsides to this is now you know, if you have an existing app or whatever, you have to switch to their templating system. You have to be okay with having these angle brackets in your JavaScript. Some people don't like that. I'm one of them. You have to use, you know, their virtual DOM setup and their application patterns. Really, I mean, if you're gonna go React, like you kind of should just go React to some degree. And you know, so the thing that I've always been fighting with is like, can we just like steal their best ideas here, right? Because like there's some cool stuff in there. The thing that I don't like is having to tightly couple, you know, that type of architecture with a particular template. Like, why? If I've already got something I'm happy with, like conceptually, it'd be really awesome if we could do this with strings, right? I mean, conceptually, if we could do this performantly with strings, it'd be really cool. And then we can generate that HTML string using any template library we wanted to, right? So what would we have to do in order to do this, right? First of all, we can't just like diff two HTML strings. Like you have to understand what they're containing, right? So you have to parse it, because otherwise you don't know, you know, you have to understand what elements are in order to get an intelligent diff out of them, right? So you have to parse it into some sort of AST or virtual DOM. You then have to diff that AST, that abstract syntax tree, if you're not familiar with that, against whatever the last one was, right, conceptually, or against the DOM. And then you have to generate a set of DOM transformation functions from that diff. All right, that's what we'd have to do, and then apply them to the DOM. So conceptually, those are the steps necessary to do this, right? And individually, those are all solved problems. There's really performant HTML parsers in JavaScript. There's virtual DOM implementations that are not Reacts, and but the big question is, can we do this performantly, and can we do it without like sending tons and tons of crazy JavaScript down to the client? So everybody knows that you shouldn't write an HTML parser, right? And especially one with regular expressions, right? Everyone's seen this wonderful Stack Overflow question? But see, I think there's a flaw in this logic, in that because we're not parsing arbitrary HTML, we're parsing HTML that we just generated, right? I agree. You shouldn't parse arbitrary HTML with regex. You shouldn't do it. But what if we make a few simplifying assumptions? And the reason you shouldn't, if you're not familiar, is because HTML is a complex spec. You can leave. You don't have to close all your tags. You can have a list with just opening LIs that never get closed, and the browser should be able to deal with that. There's all sorts of rules about how it's supposed to fail. In the cases where you have malformed HTML. So conceptually, you shouldn't parse arbitrary HTML. But if we for example say that, hey, guess what? Close all your tags. All of a sudden, it becomes a hell of a lot simpler. So let me show you just kind of what we threw together, and you can tell me I'm crazy. So what we did here is, as a mix-in, we wrote this Vdom mix-in thing that you see we're extending here. And then everything else looks pretty much like a backbone view, right? We have this template here, and that's just going to generate the whole new string that we want. And then in our render function, we're just calling this render with template thing, passing in the attributes, right? What that mix-in does, if you look at it here, so this render with template, it's figuring out whether it's the first render, determines whether your template is just a plain string and deals with that if it is already, which means that you don't have to do any of this stuff, or if it's a function, calls it, etc. And then what we do here is we parse the resulting HTML template, and then we run it through this AST to Vdom thing, which basically takes the AST that parser creates and then turns it into an implementation. There's a project out there called Virtual DOM, link coming up in a future slide. That's basically just that virtual DOM portion of React. It's not from React, but it's the same concept. And so then we generate this AST, and then once we have it, we store it and cache it. So now we're just diffing ASTs on each render, right, or each virtual DOMs on each render, and applying any diffs that come out of that to our HTML, right? So when it's all said and done here, we're patching this element with the patches, and there's a few things in here that are a little wonky just because we want to handle both Ampersand and Backbone with a single mixin. The parser is all of 75 lines. And it's got some pretty good tests, and it's pretty quick. Obviously, there's work to be done here. We're talking like 5 days worth of random hacking here while trying to prepare for this talk as well. So definitely not bulletproof, but I mean surprisingly good. So let's see how this actually performs. So some of you have seen this this test that Jeremy created, where kind of the circles moving around. So what we did is we added an input element to that. And just to kind of show how this works. So if we run it with Backbone, this kind of thing, right? So it's looping, getting in roughly 18, 19, depending on the mood of my computer, it seems. It's roughly in this range, right? So again, and now we can't retain focus here because these are constantly being re-rendered, right? Now this version is the one that's using HTML strings, literally creating new HTML strings, parsing it, etc. And what we end up with, something not too far off. It's basically the same speed. And now, we retain focus, right? Which is kind of neat. And, we've got a ways to go here. I mean, it's not perfect, but, it's really fascinating, right? Like, we can take a few pieces from what they've been doing in React and kind of abstract some things out of it and steal some ideas. This is the project that we're using for this very cool thing. Right now we're using this because this was the easiest thing to grab and use to kind of diffing things. Arguably, there's some optimizations we can make here as well. We might end up using something different, but that's what we're using right now. And so then what's the actual value? Obviously, simpler views. You have to do less glue code, less bindings, and much easier to understand, much easier to reason about, much easier to drop a new developer who's used to back-end server-side HTML rendering and just being able to use that stuff. Use those skills here as well. Initial findings, roughly the same performance as the replace in Backbone. The file size is tiny. You're adding, minified and G's up 7 kilobytes of code to your project, and all of a sudden you get nearly equivalent performance React-style rendering in your templates without changing really anything else. You're just adding a mix-in, right? So I think that's powerful. And the other thing that if you've done any React, one of the cool things that they do as well is kind of this nested view components, and Ember is doing the same thing with Ember components, where you can kind of have this. There's tags that have custom special meanings that are really views, right? So we can actually do this as well. I didn't show that here, but because it's still a little bit shaky. But we can do the same thing there. So things like rendering a collection, for example. Normally, what we do is do something like Marionette's render collection, or we have the same thing in Ampersand, where you really have to create this other object that manages that instead of just writing it in. So what you can do here is you can actually just loop in your template and create these kind of custom components. And again, because it's kind of using kind of the HTML component syntax for this, if it hits a known registered component type in the tag, then it will instantiate the view for that and pass in the appropriate models and stuff that you specify in there. So this works with any template language, because ultimately you're just producing these HTML strings that we're using for this. So the nested view stuff and subviews can be done in this way as well. So whether or not to show a subview can just be a simple if in your template, and you're done. And you retain your choice of templating languages. So yeah, we've got this mixin that works with both Backbone and Ampersand right now. We're going to optimize the crap out of it because right now it's very much just quick hacking. The mixin code is there. I'll share my slides later so you can see it because these are hard to read. And then the little parser is there. The other thing about the parser is we have a stringify method as well. So it's very much like JSON. You get your parse and stringify methods. And what that means is, it's very easy to kind of turn your AST back into a string at any point you want, which can be useful for server-side rendering. But the current flow looks something like this. Any templating language, HTML string, parse it into an AST, generate the virtual DOM, get the diff, apply DOM transformations. There's lots of steps. And very likely, there's a few things we could do here too. So we've experimented with taking a templating language that isn't just doing string concatenation, say something like Jade, and that compiles into something else, and then instead of compiling to the string, just compiling directly to the AST. So we can potentially skip that step as well, right? You can still retain that flexibility, but if you want to optimize, if you make your template return that instead, then you're kind of ahead of the game. And potentially, we might be able to just diff the ASTs. If we can do this fast enough, then we can cut out even more complexity. There's the Vdom stuff is great, and it gets us a lot of stuff for free, but there might be a few things that we can do to tweak it and that we want to do. So that's much experimentation yet to be done, but potentially this could be optimized further. And then other things, like you might be able to do, isomorphic apps more simply in this approach, right? Because you can render your application, mutate that AST and then just do toString, and you've got your views, right? And then, other interesting ideas, like maybe we could do the parsing in a web worker just to optimize things a little bit. I don't know if it's faster, but we should try. There's lots of things that this enables when you can serialize your view state, basically your DOM state. anyway, I think the thing that I want to leave you guys with is just that, you know, I think we should really, instead of just kind of jumping into, you know, hopping onto the next bandwagon that comes along and this is the coolest, newest thing that's out there, like, I think it's important that we kind of remember that at one point everything was the hot new thing. And, you know, I think we should really work on building, you know, much more flexible, much more decoupled, much more modular approaches, because arguably that's what made Backbone successful to begin with. You know, being able to use it in lots of different ways for lots of different things. And I want to see that work continue, not just the, hey, let's build a whole new framework that does all this new stuff. Right, so, you know, that's kind of my call to action for you guys. Like, just let's push these things a little bit and not just assume that someone else is going to solve these problems for us. Right? So those are the links: Ampersand, the AMP project, and the view mixin. Again, I'll post these slides in a little bit. And that's all I got. Thank you.